Hello, hello, hello. My name is Kristen Gutu, and this is Technically Biased, the podcast that discusses bias in tech, because all we really need right now is another podcast. I do think it's about time, since I've been spending the better part of 2 years telling everyone I meet about the harms of predatory tech and algorithmic oppression. And so I want to thank everyone that humored countless discussions regarding ethical tech, because you have all been instrumental to my practicing for this show. And as many of you lovely people have heard me say time and time again, a common misconception is that artificial intelligence and machine learning cannot be biased because they are neutral algorithms that build computational formulas based on the training data they are fed, which is exactly where the bias starts. Training data, just as the name implies, is a set of data used to train a machine learning algorithm. The quality and quantity of the training data are critical factors in the success of a machine learning model. It is worth noting that I do not think that the biases being perpetuated by tech are always intentional. Honestly, I hope they are rarely intentional. That said, this does not diminish the harm they cause. Just because we don't have a mad scientist behind the screen coding predatory algorithms to intentionally ruin lives does not mean that lives are not being negatively impacted. And unfortunately, those that are impacted the most tend to be the groups that are already marginalized. Algorithmic bias refers to the phenomenon where AI algorithms or machine learning systems systematically produce unfair or discriminatory outcomes or predictions based on certain characteristics, such as race, gender, age, or socioeconomic status, among others. It can occur for several reasons, such as biased training data, which I mentioned, flawed algorithms, or inadequate testing or evaluation. If an AI algorithm is trained on biased data that contains disproportionate representations of certain groups, or relies on inaccurate assumptions or stereotypes, it may lead to biased or unfair decisions, such as rejecting job applications from certain genders or offering higher loan rates to certain ethnic groups. Both very real examples that will be discussed further in today's and next week's episode. So we must understand that our perspective and our lived experiences impact the way that we write code, the way we build technology, and the people we build that technology for. The thing with machine learning algorithms and bias is that an algorithm is going to take everything literally, and it's starting to distort our relationship with language. If you think about it, language is an art that relies on context. It is beautiful, and you need to understand not just the literal definitions of words, but the slang, double entendres, similes, metaphors, synonyms, what have you. Language is something that's malleable, that can be reshaped, and that constantly evolves. It matters who's using it, how they're using it, if it's satirical or not. So there are many layers to language. And when we truly understand the art of language, we can better appreciate how intricate it is, and that AI is never going to master any human art form because it will never be able to contextualize information in the same way that people do. And so we need to realize that this AI hype is really just that. It's hype. It cannot replace us, it will not replace us, but it will pose issues for us, and it will create biases. So in America in 2023, where almost 90% of our AI experts are male and almost 70% are white, whether or not we have malintent, the fact of the matter is that their perspective is going to influence the way they write code. We have a homogenized group of people writing code, not just for a diverse nation, but on a global scale. And so their experiences are going to affect the way they build technology for an international audience. And again, I do not think that most coders start their day gearing up to ruin someone's life. But at the end of the day, their perspective is different from the majority of those who they are writing code for. And language is important. The way I, a white woman, uses language is very different from that of a man or non-binary person, especially when we introduce intersectional identities. This is simply because language is used to voice our lived experiences, and everyone has a different perspective to share. To give you a little perspective, a great book everyone should look into is called Word Slut, A Feminist Guide to Taking Back the English Language by Amanda Montell. And in Word Slut, Montell writes, and I quote, that one of the sneakiest ways biases show up is that in our language, as in our culture, maleness is seen as the default. This thinking manifests in countless contexts. But first, we can consider the idea that, in a sense, man and person are oftentimes synonymous in English. She continues to say that gendered thinking is encoded in our colossal vocabulary of sexualized terms for women, i.e. hoe, tramp, skank, etc., for which there is no male parallel. Even positive gendered language shapes how we see ourselves. Just think of the exceptionally gendered compliments we receive as young children. Montel then references the linguist Deborah Cameron, saying that praise for little boys is more likely to include words like smart and clever, while for little girls it's more about pretty and cute. One of the most significant takeaways I took from Montel's book is, and again I quote, a survey of gendered insults conducted at UCLA found that approximately 90% of recorded slang words for women were negative, compared to only 46% of recorded words for men. So, if our language is so gendered and so much more negative towards the female gender, and this does not even include or make room for non-binary people, then we need to realize that an algorithm which places people into boxes to better classify them is not going to understand the nuances of our language and how that impacts the code being written. So to give a trivial example, if I were to say, hey guys, let's go to the bar, an algorithm might pick that up and take guys, which can be used as a gender-neutral term, and interpret it to mean that more men go to the bar than women. It can then start targeting men more than women and non-binary people with ads and discounts for bars that are not being targeted towards other people. So even if there wasn't already a gender disparity in the audience of those going to a bar, the algorithm might create one by better promoting these places to men over anyone else, simply because it took my language literally. And so it's important to understand how our language evolves because this will affect the way that we write our code. Another example Montel mentions are the words buddy and sissy, which were both originally slang for the terms brother and sister. However, buddy evolves to mean a great pal or friend, while sissy evolves to describe a wimp or a sis. And why is this important? Why do I mention this? The reason is because we need to understand how an algorithm interprets language and how it calculates an output. An algorithm is just a mathematical formula, and before I lose anyone, stick with me. It's not super scary, it's not this cryptic unknown, but it does require specific constraints to ensure that the algorithm produces the correct output. To define an algorithm, each function needs to be precisely defined and measured. This means that each step in the algorithm must be well-defined and unambiguous so that the computer can follow it correctly. If anyone has ever calculated their GPA at the end of the semester to see what grade they need on their project or on their exam to get whatever letter grade they want, then you already know how an algorithm works. Every variable is given a different weight. Whether your homework is 10% of the grade and the final is 60%, it doesn't matter. It's similar to an algorithm that tries to calculate the best possible person for a job. So this is where neural networks come in, and artificial neural networks were created to mimic biological neural networks. And something that's so great about neural networks is that they often have high accuracy rates, but at the expense of high accuracy is transparency. So it's a trade-off. The more transparent the algorithm, the less accurate, and the more accurate the algorithm, the less transparent. But that means that we don't always know how the algorithm calculates the formula. So if we are trying to find someone that's best for the job and we just feed it the training data we have, we might not realize what the algorithm picks up on. So if the most common similarity among each of the applicants is gender, the algorithm might interpret that variable as the most significant piece of information and weigh it the heaviest. And so, if we don't see what's being calculated, then the wrong things might be calculated. And you might be asking yourself, well, why are you using this example? It seems so trivial, so avoidable, so silly. Who would make that mistake? Enter Amazon. So a couple of years ago, Amazon decided, we need a software engineer. And based on the current engineers that they had, they created an algorithm to sift through all the incoming resumes so that only the best resumes were seen by human hiring managers. And understandably, they based this algorithm on their current employees, aka the training data. However, they did not look at the formula, and they did not look at what the formula was weighing. And it did so happen that the most common similarity among their employees was the gender. That is fine. However, an algorithm that doesn't know better doesn't know that gender is not directly correlated. And nobody looked at the algorithm to mitigate this issue. And so, after X amount of time, they decided to look at the algorithm and the hidden layers as to better understand why they were receiving the outputs that they were. And they realized what they were calculating. And another arguably worse, I'm not even sure if it's arguable, but another example of biases being perpetuated is in 2015 when Google's image tagging algorithm accidentally tagged Black people as gorillas. Oops. And so why was this? The simple answer is that Google's training data did not include enough images of Black people. It's that simple. It had insane amounts of images of white people, and it did just fine analyzing a white person and identifying them. But it was unable to identify Black people, as I just mentioned. And this creates further issues when we see countries like China and Zimbabwe working together. Zimbabwe to provide photos of Black people to China, and China to build a facial recognition technology, despite Zimbabwe having a racist history of its own. And based on the images of Black people provided to it by Zimbabwe, China was able to build this algorithm, even though we see China perpetuate their own racism through facial recognition technology by identifying Muslim Uyghurs, apologies if I said that wrong, and using that technology to further impose discrimination and genocide on the Muslim Uyghurs. And so going back to Google, how did they resolve the issue of accidentally identifying Black people as gorillas? Well, they should have resolved the issue by increasing their training data on Black people, but no. They quote-unquote resolved the issue by taking out all the training data on gorillas. So instead of teaching the algorithm how to properly identify Black people, they taught the algorithm, or they rather untaught the algorithm, how to make the same mistake of accidentally identifying them as gorillas. And you might be wondering, well, this was 2015. Google has gotten better since then, right? Unfortunately not. To quote Meredith Broussard in her new book, More Than a Glitch, Confronting Race, Gender, and Ability Bias in Tech, which she will be discussing on this show in our next episode, Google's 2019 annual diversity report shows that the global tech giant has only 3% Black employees. Only 2% of its new hires that year were Black and women. Black, Latinx, and Native American employees leave Google at the highest rates, suggesting that the company's climate and its pipeline need serious work. Many might immediately turn to the argument of meritocracy here, which I will continue to argue on this show. In short, however, these companies do not create a safe environment for most non-white males. This is not to generalize, as I'm sure many of you might think I am, but to reference Susan Fowler's book, Whistleblower, My Journey to Silicon Valley and Fight for Justice at Uber. Men in managerial positions at Uber at this time were propositioning women for sex and sexual advances, and even devised a diversity bonus after women were leaving the most toxic team in droves. The idea went that if managers were able to maintain diversity within their team, then they should be lauded for their managerial expertise. However, since employees could only transfer teams given they had strong performance reviews from their managers, male managers started giving poor reviews in order to block women from leaving the team. They were then financially rewarded for their toxic behavior and entrapment of their junior employees. Now again, I want to emphasize that this is not an attack on men or on white people, and more specifically on white men. This is simply an example of how power structures work and why we see such disparities in gender, race, and ability in the tech environment. It is not meritocracy, but rather abusive systems awarding those who learn to be more creative in their abuse. And so, to divert back, the fact of the matter is that perspective does influence the way that we write code. Even those who have no malintent are a product of their environment, and a primarily white male environment is going to affect how even the best of us view others. According to Google itself, the priming effect occurs when an individual's exposure to certain stimulus influences his or her response to a subsequent stimulus, without any awareness of the connection. These stimuli are often related to words or images that people see during their day-to-day lives. So, when we test products on ourselves and on those around us and see that the products are working well, it is not uncommon for us to assume that the products would benefit everyone. This is unconscious bias. We are all prone to it. It is not specific to any one demographic. However, this is why we see artificial intelligence accurately identifying white men 99% of the time, white women roughly 88% of the time, dark-skinned men roughly 75% of the time, and dark-skinned women roughly 65% of the time. So again, it is very important to use intersectional identities in the training data we use. This is a very easy way to resolve the issue, and I'm actually going to reference Meredith Broussard's new book again because she focuses on this so much. A more recent example is how, quote, Google trained its skin AI on 64,837 images sourced from 16,114 cases in 2 U.S. states. The patients are mostly people with light or medium-toned skin. Only 3.5% of the images came from patients with darker skin. The training sets, like most of the medical textbooks, include only light skin. The skin cancer AIs are likely to work only on light skin because that is what is in the training data. I do not think coders are malintended, but I do think we need to increase the training data to include more diversity. This is common sense. More data does not mean better data. We need to include intersectional identities in our algorithms. And to quote Broussard's book one last time, EdTech surveillance systems do not recognize people with dark skin, religious headwear, or facial features that diverge from the most typical shapes and patterns, end quote. Now, this may be a stretch to some, but to reference everything going on in America currently, and to reiterate my comment of how China is using facial recognition technology to target and harm the Uyghur population, this made me think of the Martin Niemöller quote referencing the Holocaust. First, they came for the socialists, and I did not speak out, because I was not a socialist. Then they came for the trade unionists, and I did not speak out because I was not a trade unionist. Then they came for the Jews, and I did not speak out because I was not a Jew. Then they came for me, and there was no one left to speak for me, end quote. This is not a stretch. We need to be more inclusive because whether or not it is intended, technology is catering to a very specific demographic at the expense of others. I hope you will tune in for next week's episode with Meredith Broussard, who will offer more insights into her book and how we perpetuate biases in tech.